Distinguishing these two types of data is important to avoid confusion. The dependency of test case data on product data can be brittle. For example, consider our test case step to create a new loan application for a home mortgage. This step works as long as the bank's web app is configured for quote-unquote home mortgages. However, the product data could be changed at any time, just like product code. What if the specifics of a home mortgage loan application change? What if the loan is no longer called a home mortgage loan, but a personal residential loan? Something that simple. That could and possibly would make the test case break. Compounding breakages will cause nightmares for test management. So, how should we manage test data? For feature testing, test data is just as important as test cases and test code, just like I said. How do we handle both product data and test case data together? Are there strategies we can use to avoid brittle dependencies? So as I said before, we're going to explore multiple ways to handle both the product data and the test case data. There are no universal or perfect solutions to the test data problem, but you can avoid nightmares by picking the strategies that work well for your needs. Let's start with product data. As stated previously, product data is any live data in the product or system under test. In simplest terms, it's everything in the database. Things could include user accounts, administration settings, product customizations, records, and files uploaded by the user. With our banking app that we were talking about, product data would be things like the user accounts, the loan products that would be priced, completed applications from customers, and also all that behind-the-scenes bank data, the funding curves, the indices. Oh boy, wow, that takes me back. Data must be present in the product as a prerequisite for most testing. There are two primary ways to get that data in the system. On one hand, you can set up the data before running tests. This will be called static data creation. For example, the loan web app could be set up with a set of pre-registered customers and a collection of loan types. Test cases, whether manual or automated, can presume that the static data is already in the system and simply reference it. Static data preparation is a good strategy for complicated data or data that is slow to create dynamically. For example, with user accounts, you may need email verification to create them. So it might be easier for automated tests to simply use a set of pre-registered users rather than create them on the fly. Tests will run faster if they can simply reference existing data instead of creating new data each time as well. However, static data must be maintained. Any changes to static data could also impact tests. Static data may also become stale over time. Think about things like data fields or stuff like that, or things that are time sensitive, like a time series. Instead of static data prep, you could also consider dynamic data prep. This would be creating data during test execution. In the example of the loan test case, the loan application document is dynamically created during each test. The test does not reference an existing application, it creates a new one. Dynamically created records avoid the brittleness of hard references to static data. They can also be used exclusively by the current test case, namely for automation, pardon me, which protects it from being interrupted by other test cases or actors. The main downside of dynamic data prep is the execution time. It does slow down your tests every time you have to create something fresh. Dynamic data is essentially disposable too, so at some point you ought to clean it up or else you might fill up your file system. Which strategy is best? Typically, testing requires both strategies together. Data that is slow to set up or considered immutable should use static preparation, while data that is quick and easy to set up should use dynamic preparation. When I develop test solutions, I prefer to create as much data as possible dynamically per test case to preserve test case independence. When a test creates the data it needs dynamically, it will be the only test using that data, and there is a much lower risk of collisions. These two data prep strategies are a bit complicated when implementing them. The dynamic prep strategy depends really upon the test cases using it, so it's very context specific, like if I'm creating a loan application or I'm entering in certain fields. So that depends per test or per behavior, I would even say. But static prep does have a few general strategies that are independent of any test cases. Let's take a look at those. The simplest data prep strategy is manual configuration. And that's exactly what it sounds like. Testers log into the system and manually create whatever records they need to be in the system. That could include creating users, configuring settings, saving records. For our loan app, that could be configuring loan products. The nice thing about this is that anybody can do it. It's low tech. You don't need fancy tools or frameworks. You just get in there and sound effects not included. However, manual configuration is slow. It does not scale well for large systems or large test environments. Furthermore, manually configured systems can easily fall into disrepair without any sort of automated mechanisms for maintenance, because you pop it in once and it's there until you change it. A better strategy might be automated configuration. Rather than manually setting everything up, automated tools can create the desired data. This could be accomplished in many ways. You could reuse UI interactions from any tests you've automated. You could call REST APIs, or even possibly use tools like Puppet or Chef or some sort of configuration management. Automation could generate data deterministically or randomly, depending on your needs. The main benefit of automation is the ability to create fresh data at any time. Automation can also clean data, like scrubbing private fields or updating time-sensitive fields. However, it's not a free lunch, unlike what we're getting today. With automation, it requires extra skills, extra tools, and you've got to keep everything maintained. If you want a shortcut, you could always try to clone databases. Cloning databases is easier than ever with our cloud management tools we have available. You could create one database and put it in a golden state, and then just clone that every time you launch the test suite again. That way, everything is fresh, everything is the way it's supposed to be, and you don't have to worry about any sort of granular setup or tweak this, tweak that. Database clones make it easy to copy all data at once. But what if your database has a lot of data? I mean, we're talking gigabytes. That might not be pragmatic, even if it is easy to push the big red button to clone. Also, clones may need some extra refinement to scrub special fields and hook things up properly. So that's not the final answer here. If managing real data is too much of a hassle, you could always try to mock your endpoints. This would completely remove the dependencies on databases and even some services in your ecosystem. All the data returned by mocks would be completely under your control. So you can make it deterministic, you can make it yield random results, whatever you need. But mocks are not always the right solution either. They often require a lot of setup, and mock data can make tests overlook unpredicted real-world variations. Mocks also mean that you're not truly testing your things end to end. These strategies can also work together. It's not pick one and ignore the others. For example, you could use automated scripts to configure product data in a golden database, and then you can make clones of that database. In another example, in a large testing environment, you could selectively choose some things to mock while using real data in others. Many times, we want to use production data or production-like data in our systems to mirror the real world. Unfortunately, production data has personally identifiable information in it. It's not easy or safe to share, And many things like credit card numbers and social security numbers must be kept private. Another strategy would be generating data synthetically based on production-like systems. Generating synthetic data is a great way to avoid common roadblocks you hit. There are plenty of tools out there. One that I've seen is Gretel AI. Another one is Tonic. I know synthetic data has become kind of a buzzword recently, but the idea is not just that it's mock data, but rather that it is statistically accurate compared to what you're having in your own production environments. And so this could be another strategy for your static data preparation. There are multiple factors that should be considered when deciding which of those strategies is best for you regarding static data prep. So here are some things to ask yourself. First of all, how big is the data? If you're talking about small things, manual configuration is probably going to be just fine. If you got a lot to deal with, banking data, then maybe you should invest in automation. Another thing is, how fresh does the data need to be? If your data is time sensitive, then you really will need some sort of automated tool to keep your data up to date or to scrub fields. How frequently will the data need to be updated? Again, automation or even synthetic data can help here. How difficult will it be to try advanced tricks like mocking or cloning databases? This might be a challenge in legacy systems. Is there any bureaucracy in the way of the solutions you want to do? I mean, hey, it happens. Just because as developers we say we want something doesn't mean we get it. Not every organization will be able to support whatever ideas you come up with. So be cautious here. Also, do folks have the skills required for automation or database administration or mocks or synthetic data? Skill level may be a barrier at first, but this should not be an end to the story. There's plenty of places people can go to learn things. I mean, heck, Test Automation University, boo, another plug. So this is something that we can easily overcome. And finally, what is the cost? Each data prep strategy has a cost. So when you're considering and debating these strategies, you should be also doing a cost-benefit analysis. So that's how to handle product data. What about test case data? Let's look at that next. Test case data is inherently part of test cases. So let's revisit our example test case from earlier. As we said before, there are multiple bits of test data throughout the steps of this rather short scenario. And they each represent different types of test case data. First, let's look at the top step. Given the Chrome browser is open. The Chrome browser is test data because it specifies the type of web browser in which to load the web app. This is what we call a test control input. It directs how tests will run rather than specifying feature behavior. Theoretically, this test should run the same on any browser type, but the steps here dictate that the test should run on Chrome. As a recommended practice, test control inputs should not be hard-coded into test automation code. Please don't do that. Instead, they should be passed into automation as inputs. That way, tests can easily be retargeted. There's a couple ways to do this. The simple way would be to create a flat file with input values. I recommend using a format like JSON or YAML because they are easy to write, easy to read, and easy for programming languages to parse. Excuse me. For example, in Python in the standard library, there's a JSON module that will turn any JSON file or text string or whatever into a dictionary in 2 lines flat. Another nice thing about flat files like this is they can also have line-by-line diffs. So test automation code can read in the file like this before any tests start, and it can inject input values as appropriate. For example, in this particular JSON file, automation could read the browser type as Chrome and construct a Selenium WebDriver instance for Chrome driver. The path for the input file would need to be hard-coded in your automation code, but it could be as simple as a standard file name like inputs.json in your current working directory. Another way to handle inputs is using environment variables. Testers could set variables from a system shell or in a profile, and automation could read those variables by name. This can be very useful for integrations with continuous integration servers like Jenkins, or if you're doing something like using Docker containers. It can be a bit more dangerous because anyone could change these variable values. You have to make sure you control your environment, but it's also a very standard practice. Again, automation can read these variables before tests run and then handle them appropriately. So let's remove that hard-coded step for the browser type for the scenario, and we can handle that as an automation level concern, not a behavior level concern. Next, let's look at a second type of test case data. Notice how the URL here is hard-coded. Again, this is not a recommended practice. Typically, development teams host multiple instances of products under development. Maybe there's like a development environment or a staging environment or a test environment. You may even be running something on your local host as well. Hard-coding configuration information like this limits where tests can be run. That's no bueno. Any information about a product, about product's configuration is called configuration metadata. This can include things like URLs, but it can also include things like usernames, passwords, and possibly some other descriptors. There are a few ways to handle configuration metadata. You can use flat files or environment variables like we did for test control inputs. That's fair. Personally, I recommend using flat files, and I also recommend separating test control inputs from, test control inputs from your configuration metadata, two separate sources or files. You can create an input to refer to a target configuration, and then store multiple configurations in multiple different config metadata files. That way, testers can change just a few simple inputs to target any configuration, and they won't need to change multiple configuration fields regularly. If you want to be fancy, you could even create a web service to provide configuration metadata. This would be especially helpful for keeping secrets like passwords safe. I've done this before with something like Azure Key Vault. However, creating such endpoints may be overkill for your needs. Again, choose what's best for your needs. Either way, this test case step can be rewritten to refer more generically to the web application rather than a hard-coded URL. Automation can select the target environment using the inputs and config metadata. The remaining pieces of test case data all fall into a category called test case values. These values pertain directly to the behavior exercised by the test, not to any configuration factor. Even in this classification, there are subtypes. The first kind of test case value is a literal value. These are values that are hard-coded in the test, and this hard coding is okay. In this example test, the table of personal information contains literal values. Literals are simple to use, and they provide specification by example. Literals should also be independent of any statically created product data. They should be values that can be safely originated by the test case. The literals in this info table will be entered as input values into the web app. So theoretically, they could really be any values. The second type of test case value is an output reference. These are values that are retrieved from the product under test. Typically, they are outputs generated by exercising a behavior. In our example test here, the reference number can be scraped from the success page and verified for correct format. The loan application can be retrieved from the web app's backend to verify that it was correctly submitted. These values cannot be literals because they originate from the product, not from the test case. Tests must refer to them by reference and retrieve their value from the product. As a side note, this test dynamically creates the Lin application, so it's an example of that dynamic data prep we saw before. The third and final type of test case value is the trickiest, and it's called the input reference. At first, these may look like literals, and they may even use literal values for references. But input references are values that directly refer to product data. While personal info like name and address are created dynamically by the test case, the name of the loan type refers to the loan configuration in the web app. Thus, the test has an input dependency. It must specify the type of loan, in this case, and that loan type must already exist in the product data. It's not created on the fly, it has to be there, and we simply reference it from the test. The simplest way to write this test is simply to hard code that reference. Now, we can say something like the name home mortgage, referring to the loan type that we want. An automation can use that name when selecting the loan type from like a button or a drop-down or text input field. We just need to make sure that that loan type is in the product when we're running our test. We could try to avoid the pain of static data references here like this using dynamically prepped data, like we did with the loan application itself. But like we said before, sometimes it may be too much to create on the fly. Another strategy you could use here is called data discovery. Let's say that the target web app already has multiple acceptable loan types. So instead of hard coding the name of the loan type, the test could describe the type of loan and then use automation to search the web app's config to find a loan type matching the desired criteria via like an API call or something. So for example, within a bank, let's say I have different regions of my bank where each region has a different name for the same kind or type of product that would be good enough to exercise the behavior you need. You could make a call more generically for a home mortgage type of loan, and maybe there's 3 loan types that match that. Discovery can find one that's appropriate and return it to you. Discovery enables tests to search existing product data so that you don't have to. And it makes tests more resilient to changes in product data, like if we fat-fingered or typoed this, or there's the staging environment is different from the dev environment for some reason. It is a powerful strategy, but again, this discovery mechanism might be overkill for your needs. Whew. So that's a lot of info about test case data. Let's do a quick review here. Test control inputs direct how tests will be run, not what behavior is covered. They should be supplied via flat files or environment variables. Configuration metadata describe product configuration for the target environment. They should be supplied via config files or possibly service API calls. And test case values direct the behavior covered by the test. They could be literals, output references, or input references. And they might be hard-coded or discovered. So, at this point, you're probably thinking, wow, that's a ton of information. Oh my gosh, overload. Are we still okay? Everybody still with me? Yes, good. It's still early in the morning. Great. So you're thinking, okay, a lot of information. That's right. We're done, right? It's time for Q&A. Not quite yet. Nightmare isn't over. Sorry. We still have one more problem to address. Collisions. 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 Collisions can happen whenever multiple actors operate on shared resources. What does that mean in plain language? Let's say you have multiple testers running tests on the same environment, or when you have automated tests running in parallel, all accessing the same resources. 2 tests could be using the same kind of record or loan type. That could be a collision. The idea of a collision is when they don't share nicely, kaboom! Then you have to call your insurance company and go through court. Additional considerations must be taken to avoid collisions. First and foremost, isolate the test environments. Prevent external actors from interrupting your tests. If you have an environment set aside for running automated tests in CI, Don't let other people get in there. If you have a shared test environment, block other people from accessing it while tests are running. This means you might need to schedule tests to run during off hours. You might also want to set up multiple test environments. If the product under test is containerized or if the databases are clonable, then you could easily dynamically create fresh environments for every test launch, which would guarantee perfect isolation. That's the dream. Not always achievable, but certainly if you can do it, do it. Second strategy, treat any shared data as immutable or unchanging. Sometimes shared product data is unavoidable. For example, if tests run in parallel against one test environment, then they could be using the same product data. Or if an application has multiple components, certain components may be difficult to isolate for testing. Whenever data must be shared, treat that data as constant or immutable. Any changes to shared data could break your tests. For example, one test might require a car loan, but another might delete the car loan type from your application. Any test that must alter shared data should be run serially instead of in parallel, and they should always undo changes that they make. The ideas of do no harm and leave no trace. Third, and finally, use dynamic data preparation as much as possible. Like I said, when I've implemented test automation projects, I've tried to do dynamic data as much as possible to keep things localized per test case. Tests can't collide on data they don't share. So minimize the amount of shared data. Keep statically prepped data to a bare minimum because it's more likely to, statically created data is more likely to be shared data, and shared data is more likely to cause collisions. Whew, we made it. We covered a lot of material in this half an hour. So let's do a quick recap of what we've learned. Get ready for your cameras because the money shot's coming. There are two types of test data to avoid ambiguity. We really have product data and test case data, separate but connected. Product data can be prepared statically or dynamically. It's baked into your product under test. It's what is there, it's what is real. Test case data can either control how tests run as sort of like a configuration thing, or it can reflect product data in it's revealing behavior. You always want to handle your references and shared data carefully. And before I go to the next slide, this will be your picture shot. 5, 4, 3, 2, 1. But overall, if there's one lesson to take home today, choose the best strategy to defeat your nightmare. Pardon me. Choose your best strategy to defeat your nightmare. Every product is different. Every team is different. I can't possibly know what challenges you're facing and what exactly you're working on today, but what I can share are different strategies that might help you that I've used in my time. So I'm hoping that there's something here that you can take to help defeat your nightmare. So thank you again so much for listening to my talk today. Again, my name is Pandy Knight. I'm the Automation Panda, developer advocate at Applitools, and director of Test Automation University, and unofficially Pokemon Master. Be sure to check out my blog at automationpanda.com. You can follow me on Twitter at automationpanda. If you would like to meet me afterwards, I can answer questions. I actually have little panda stickers amongst other little goodies. And I hope you enjoyed the rest of All Things Open here in Raleigh, North Carolina. Thank you.